Welcome back, everyone. I hope you've answered the questions on the previous slides. No, I am not eating one of my audience members. Anyways, let's talk about topographic maps. A topographic map is a map that shows the shape of the land using contour lines. And a contour line is a line on a topographic map connecting all points with the same elevation. So in the top right, this is pretty much what you'll see when you're looking at a topographic map. In the lower left, you can see this picture which shows how they work. Imagine this picture here, that is kind of like that is what the landform looks like. It's kind of like a raised mountain or a raised hill. The index contour are these dark solid lines labeled with the elevation above sea level. And the contour lines are all of these kind of lines connecting. So everything on this line labeled 200 is 200 meters, let's say meters, 200 meters up. Everything on the 100 line is 100 meters up. And you can see the top of this landform here. So you can see it here. You can see the bottom is here. Now here's a good image I want y'all to see on the right. If this is what this little mountain looks like from the side, this is what it would look like as a contour map. I'm going to go back to try to get rid of that. Yeah, so now you can see the peak here matches the peak here. The peak here matches the peak here. These lines connect the sections of elevation to where they are on the map. And I want y'all to notice it's pretty steep here. Steep is kind of like that. Not so steep would be more like that, more flat. So we got steep and not steep. This side is really steep. Notice how the contour lines are close together. And now this side here, you can see it's still a little steep, but it's more flatter. It's a little flatter. It's not as steep. Notice how the contour lines are more spread out here. They're not as close together. So steep, the lines are close together. Not steep, they'll be more spread out. You can see it's not very steep here. Okay. So elevation as shown on a topographic map is the actual distance above sea level. So for example, Carrollton, Texas is about 700 feet or 220 meters above sea level. We're above the level of the ocean. So Mount Everest is 8,850 meters above sea level. So you get the idea. Anyways, a contour interval is the difference in elevation between two contour lines that are side by side. Basically, from on this picture here, you can see this line is 700 feet above sea level. From this line to the next is 20 feet. So this would be 7. And then to the next one is 20 more feet, 20 more, etc. So this would be 700 feet, then 720, then 740, 760, 780, and then 800. The contour interval will often be labeled on a map. If it's not, you can usually calculate it by finding two index contours like 700 to 800, subtracting them from each other, then count the number of lines between them and take whatever number you get and divide it by the number of those lines. So 800 minus 700 is 100. Then there's 1, 2, 3, 4, 5 total lines. If you're counting from 700 to 800, you count 5 lines. So take 100 divided by 5 and you get 20 feet. So those are index contours, are the ones that are labeled. So you can see these are contour lines, the contour intervals, the distance between them. Here you can see this is an example of if the contour lines were placed on a three-dimensional picture. All right, moving on. Again, when contour lines are close together, like right here, that indicates an area has a steep slope, very, very steep right here. And when they're far apart, it's more flat. It's not as steep. So any questions about that, just shoot me an email. Otherwise, here's another picture that shows the steep side is represented with close lines that are close together. The flatter side is represented with lines that are far apart. All right, here's another picture of some index contour lines. I'm not going to dwell on this, but these are the index contours, are the thicker ones that are labeled with their elevation. The lines in between, you can calculate their elevation change by subtracting these again. 750 minus 700 would be 50. You count, there's 1, 2, 3, 4, 5 lines between. 50 divided by 5 is 10, so 710, 720, 730, 740, 750. That makes sense. Generally, the index contours are every 5th line. That's usually the way they're done. All right. Now, this is an example of some features you can see on a topographic map. A depression